Hello everyone, this is Raghavi, Assistant Professor from Computer Science Department. Today we are going to see about the concept image segmentation in digital image processing. First, let us see about the image segmentation. Image segmentation is the process of dividing an image into different regions such that each region is homogeneous. We can extract some information by analyzing them, and this information is useful for high-level machine vision application. Image segmentation is considered as an important basic operation for meaningful analysis and interpretation of image acquired. It is a critical and essential component of an image analysis or a pattern recognition system, and is one of the most difficult tasks in image processing, which determines the quality of final segmentation. It is the primary area of research in computer vision. A number of image segmentation techniques are available, but there is no one single technique that is suitable to all the applications. Next, let us see about the detection and discontinuities. This is usually accomplished by applying a suitable mask to the image. Mask is nothing but segmenting a specific portion from an image. Next, the segmentation algorithms are generally based on two basic properties of gray level values. First one is discontinuity, that is based on isolated points, lines and edges of image. The next one is similarity, that is thresholding, region growing, region splitting and merging. First comes point detection. A point is the most basic type of discontinuity in a digital image. The most common approach to find discontinuity is to run a encroach and mask over each point in the image. The point is detected at a location x, y in an image where the mask is centered. If the corresponding value of r such that the absolute of r should be greater than t, where r is the response of the mask at any point in the image and t is the non-negative threshold value. T means the isolated point is detected at the corresponding value x, y. This formulation serves us to measure the weighted differences between the center point and its neighbors, since the gray level of an isolated point will be very different from that of its neighbors. Since the gray level of an isolated point will be different, the result of the point detection is shown in the below figure. That is the original image. After performing the point detection, the resultant we get is the second image. Next comes line detection. Line detection is the next level of complexity in the direction of image discontinuity. For any point in the image, a response can be calculated that will show which direction the point of a line is most associated with. For line detection, we use two masks, and the mask is represented as Ri or Rj should be greater than Ri should be greater than the absolute of Rj, which is not equal to j not equal to I. It means that the corresponding points is more likely to be associated with the line in the direction of the mask. Next, with the help of the line detector mask, we can detect the lines in a specified direction. Next comes the edge detection. Edge detection is the most common approach in the gray level discontinuity segmentation. An edge is the boundary between two regions having distinct intensity level. It is very useful in detecting a discontinuity in an image when the image changes from dark to white and vice versa. The changes of intensity are represented by the first order and a second order derivative, as shown in the image given below. That is from how the intensity varies from dark to white and from white to dark. We can find out the strength and direction of the edge at a particular location x, y. Next, let us see about the first order derivatives. A first order derivatives response when there is discontinuity in a intensity level. It is positive at the leading edge and negative at the trailing edge. The first order derivatives include some operators. The first one is a privet edge operator. This helps us to find the horizontal edge that is equivalent to a gradient in the vertical direction, and the mass that computes the vertical edges that is equivalent to the gradient in the horizontal direction. Next comes the Sobel edge detector. It gives the averaging effect over an image. It considers the effect due to the spurious noise in the image. It is preferable over the privet edge operator because it gives the smoothing effect, and it also reduces the spurious edges which are generated because of the noise present in the image. Next comes second order derivatives. It is positive at the darker side and negative at the white side. It is very sensitive to the noise present in an image, so it is not used for edge detection. But it is very useful for extracting some secondary information. That is, we can find out whether the point lies on the darker side or on a whiter side. It includes zero crossing. It is useful to identify the exact location of the edge where there is a gradual transition of intensity from dark to bright regions and vice versa. This second order derivative also includes some operators. The first one is Laplacian operator. The Laplacian operator uses 8 mask connectivity. This is used to reduce the effect of noise. The first image will be smooth using the Gaussian operator, and then it is operated by the Laplacian operator. These two operations together is called as a log, that is Laplacian of Gaussian. Next, let us see about the log operator. The image given below shows the mask that the log operator uses. Next, let's see about the Canny operator. It is very important method to find edges by isolating a noise from the image without affecting the features of the edges in the image, and then applying the intensity to find the edges in the image and the critical value for the threshold. Convolve the image f of r comma c with the Gaussian function to smoothen the image, that is g of r comma c, and it is given by the mathematical formula as r comma c equals to f of r comma c in asterisk g of r comma c, that star represents the convolution. Next step, this Canny edge detector first applies the difference gradient operator to compute edge strength. Next, it performs non-maximal or critical suppression to find the gradient magnitude, and finally it uploads the threshold to the non-maximal suppression in image. Thank you for watching.